Okay, let's go over these percent problems real quick. We're going to be on the side of this. I know it's only two sides. It talks about the item's original price is $40. It's marked 20% off. Find the new price. You see that word off? Put a minus sign in front of that. So when you have a percent and an addition or subtraction, that tells you you're going to the formula. It's the new times the percent, or the original, excuse me, times percent equals new. So original, and it's a tried and true method. It works every time I have a percent and then a minus or a plus. So original times percent equals new. Okay, now let's see what we're going to do to find our percent. So we're going to take 100%, because that would be a whole, and we're just going to minus that 20%. That gives me 80%. Now to put a percent into an algebra equation, it needs to be divided by 100. So we're going to divide 80 by 100. That's 0.8. Okay? So 0.8 is the factor I use for my percent. And now, read the sentence with the 40. It says the item's original price is $40. So 40 is the original. And then X is what I'm trying to figure out. Now it says find the new price. So that's X. All right, so here, what am I doing with these two? Well, a dot means I'm multiplying. So 40 times 0.8 is $32, okay? So up here, just put 32, and whatever that label is what your answer's label will be, okay? So your new price is $32 after they've marked it 20% off. Okay, now in my next problem, an item is marked up 40% from its original price. The item's new price is $77. Find the original price. Okay, so again, now you see that word up. Now up doesn't mean minus, that would mean plus. So with pluses and minuses of percents, we go with the original times the percent equals the new. So original, percent, and new. Okay, so to find our percent factor, we take 100%. Now there's no power, there's no exponent here because the percent, it doesn't say per year. Okay, it's just the percents only occurs just one time. See, on that problem you had yesterday when you made the little box off the side, you had to use a power here, a little upside down caret, because it was happening per year. That doesn't say per year or per anything here. Okay, so that's why I don't use the power. Okay, so I add 40%, and that's 140. Now again, that needs to be divided by 100. So I take 140 divided by 100, and I get 1.4. Okay, now read the sentence with that 77, just a sentence. The item's new price is $77. So 77 is the new price. Then that means I got to figure out the original. Okay, so I can't multiply, so I do the opposite of multiply, which is divide, but you got to divide in the right order. Okay, so divide by 1.4, divide by 1.4. Okay, you just put 1.4, connect the line, put 1.4, that cancels. Then I divide 77 by 1.4. It's got to be divided like that. You got 55, so above your X you can put 55, and this label is the same as this label. Boom. Okay, next one. An item's original price is $300. It's marked up 20%. Again, up means plus, okay? So again, that tells me with a percent and a plus or a minus, we do original times percent equals new. Okay, so original times my percent equals my new. But I don't need a power because it doesn't say per year like those two problems you had yesterday. So I don't need that. Okay, so I have 100% because there's not two units. The only unit's the money. Okay, there's no other unit that is independent. Okay, it's just money. So up 20, that means plus 20%. And that takes us to 120%, and then divide by 100. So I divide 120 by 100, and that's 1.2. That's my percent. Now, read the sentence with $300. An item's original price is $300. So $300 is the original, and me, Mr. Corey John Hermson, need to find the new. So I just multiply. So 300 times 1.2. Okay, now it's 360. So an item started off here, it was marked up, and that's your new price. Okay, my next problem. An item is marked 40% off. Off means minus its original price, and the new price is $30. Find the new original price. So again, off with a percents with minuses and pluses. We go set up this base formula. Okay, so original, percent, and new. Okay. I don't need the exponent because it doesn't say per year, okay, or per day or per month or whatever. So I don't need the power. Okay, so I go 100% and then minus 40. 100 minus 40 is 60. Remember to divide it by 100. Okay, so I divide 60 by 100, and that's 0.6 for my percent factor. Okay, now read about just a sentence with the 30. It says a new price is $30. Okay, so I know the ending price, the new price is 30. And I got to find the original using the x variable. Okay, now you're not going to multiply. You're finding out what times 0.6 would equal 30. Well, I undo the multiplication of the x by connecting the line and putting 0.6 somewhere underneath there, and those cancel. And then I put 0.6 under the 30, meaning I'm dividing. 30 divided by 0.6 is 50. So I get $50. Okay, now on the back side. 30% of the school attended an assembly. There are 200 students in school. How many students attended the assembly? Now, I don't have a plus or minus word in this problem, so I don't use the same method. This becomes a proportion with part and whole, okay? So 100%'s in the bottom, and I just use the percent I'm given, 30%, okay? I don't have a plus or minus to do with the percent, which is why I'm doing it this way. Now, we have to know what the part means. You have to define the part, and it's underlined. The part is the 30% part is those that attended the assembly. Okay, now read the sentence with 200. Does it say there are 200 students in school? There are 200 students in school. It doesn't say anything about them attending an assembly. So 200 is not the part, 200s are whole. And we have to figure out the part, which is easy to do. I just cross multiply diagonally and divide by 100. 30 times 200 divided by 100. 60. Okay, if you're wondering about the label, it says 200 students, and then 60 students attended this assembly. Okay, 25% of the land in the United States is covered by forests. Forests cover 2,000 square miles. How many square miles of land are in the United States? Again, there's no plus or minus words, so it's a part whole. Okay, all right, now we need to define our part, and it's that covered by forest, the amount covered by forest. The whole would be just the whole land in the U.S., okay? All right, so we're going to put 100%, and then we're going to just put 25%. Okay, now read the sentence with the 2,000. Forests cover 2,000 square miles. Well, it says forests cover that. So 2,000 is your part, and X is the whole that we're finding, okay? Because it says forests in that sentence, then 2,000's going here. So I cross multiply and divide. 100 times 2,000 divided by 25. Okay, 8,000. If you're wondering about the label, it's 2,000 square miles, so the whole is 8,000 square miles. Okay, next one. I spend 30% of my monthly paycheck on rent. I spend $600 of my paycheck on rent. How much money is in my paycheck? All right, so with that being said, there's no words that indicate plus or minus, so I go to my part whole proportion. So part whole. Now you always have to define the part, otherwise you won't know where to put $600. Okay, it just says on rent, so just put on rent. Okay, and I use 100%, and then I just use the percent I had from the problem. I don't add or subtract because there's not a word that indicates that. Okay, now read the sentence with the $600. Does it say on rent in that sentence? I spent $600 of my paycheck on rent. Okay, so 600 is the part, X is the whole. So I cross multiply and divide. 100 times 600 divided by 30. 2,000, okay? It'd be $2,000 for the label. Okay, last problem. 60% of the animals at the zoo are reptiles. The zoo has 200 animals. How many reptiles are there? Okay, so again, no words that indicate an adding or subtracting. So it's a part whole. If you just want to put PW, that's fine, but you got to define what the part means. Reptiles. Okay, so 100%, and then it's 60 out of 100, 60%. Now that 200, does it say anything about them being reptiles? Just read from here to here, where the sentence. The zoo has 200 animals. It doesn't say that you have 200 reptiles, okay? So 200 does not go here. It belongs in the whole, and I need to find the X here. So I take 60 times 200 divided by 100. 120. Okay, now this one's a little bit confusing on the label. 200 animals. Well, I guess you could put animals that are reptiles or whatever. You can just put animals, that's fine. Because 120 animals are reptiles. Okay, moving right along. Now, simplifying expressions of polynomials. These parentheses are known as polynomials. Okay, you got a plus in the middle, so you don't do any rainbows. You need to line up your blanks. So m to the second is your highest power, plus blank m plus blank. Okay, so m to the seconds, right here and right here. So I take 4 plus negative 3. That's 1, okay? You can cross those out. And then m, that's a 1. So you have right here and right here. So negative 1, 1 is negative, plus 10 is 9. Now you're looking for constants. Those are numbers without variables. You have positive 2 and positive 7. You add those. So 2 plus 7 is 9. Okay, and that's all she wrote on that one. Okay, now the next one, I have a minus sign, so I don't need rainbows because I don't have any multiplication I have to do. So x third, x second, x second, and x. So x third is the highest x power I have in the problem, followed by blank x to the second. Then I'm going to look for just x's. Then I look for constants. So x third, I've got 9. I don't have an x third here. So that's 9 minus 0 is kind of what that is. 9. Okay, and you cross that out. Now I'm looking for x to the second. So I have this negative 13 and another negative 13. But remember, you're minusing them. So negative 13 subtract negative 13 is 0. Okay? Now, if it's 0, you can cross out the space. Don't need it. The reason I got 0 is because minus a negative is actually just adding a positive 13. So if you have a negative 13 and add a positive 13, then that would take you to 0. Okay, and you cross those out after they've been added. Now for x, well, I got one here with 1. And I have one here, negative 5. Remember, I'm subtracting. So I take 1 minus negative 5. Now I'm expecting I'm going to get 6 because it's just like 1 plus 5. 1 minus negative 5 means the same thing as 1 plus 5. 6. When you take away a negative, you're actually adding the positive number. Okay, now for constants, I don't have anything here, but I do have one here. So when I do my math, I want to punch in 0 minus 14. That's negative 14. And that's your answer. Okay, so those are pretty easy, pretty much a walk in the park. Now the annoying part starts, because this means multiply. Make sure all your x's have numbers in front. So this x here, not having anything there doesn't work. It's a 1. Now I need to distribute with my rainbows. So 3 to 8, 3 to negative 1, 3 to negative 3, and 3 to 5. Now I just drew 4 rainbows. So 3x to the third I write down 4 times over here. And then I'm going to multiply by 8 with an x to the fourth. I'm going to multiply by negative 1 with an x to the second. I'm going to multiply by negative 3 with an x, and then I'm going to multiply by positive 5, which is a constant. Okay. Now I just figure these out. I multiply the big dudes, the big dogs, 3 times 8, 24. Okay. And for x, remember what you're doing. You're taking 3 plus 4. Okay, you don't multiply the exponents. When you're multiplying, you actually add the exponents. So 3 plus 4 is 7. You know what I always tell you when they're on top together, it's adding? Well, this is the same thing. Okay, now 3 times negative 1 is negative 3. And then again, with x, we add the exponents, 3 and 2. Okay, 3 plus 2 is 5. Okay. All right, now 3 times negative 3. Negative 9. 3 and 1. So again, that's 3 plus 1. That's 4. Okay. And then 3 times 5 is 15. And then we just got x to the third. Okay, we don't have anything else. Okay. Now, if you look across here, all of these powers are different. Okay. So you just write them out with plus signs. Don't just leave it. I want the answer written out here, but you don't need to do your blanks because they're all the different powers. Okay? So you got 24x to the 7th plus negative 3x to the 5th. Keep writing plus negative 9x to the 4th plus 15x to the 3rd. Okay? And that's done. Don't draw out the blanks when they're all different powers. You don't need to do that. Okay, now, number 4. We have 2 parentheses, but there's no sign in the middle. So that means you have to multiply. Okay, so I circle the 3x, and I distribute 3x to both of these. Not to this one, because that's in the same parentheses. So 3 to 4 and 3 to 9. Now I just drew 2 arrows from the 3x. So 3x, 3x. Then we're going to multiply by 4x, and we're going to multiply by 9. I'll figure those out in a bit. Now the 3x is done, but now I got to distribute the negative 1. Okay? So I just drew 2 rainbows. So negative 1 times, negative 1 times. We're going to times it by 4x, and we're going to times it by 9. Same 2 things I did here. Now find the products. Now when you're multiplying, you want exponents on your variables. So that'd be a 1, 1, 1 and then nothing, nothing and 1. If there's no x here, don't put a 1. And then nothing at all. They're both constants. Okay, so 3 times 3 times 4 is 12, and then x, you take 1 plus 1, which is 2. 12x to the second power. Okay, 3 times 9 would be 27, and on x, you just got that little 1 there. You're not going to add to it, you just write a 1 down. Negative 4 times 1 is negative 4, and with the x, we just write the 1 down. Don't add if that's the only power you have. Negative 1 times 9 is negative 9. Okay, and you don't have any x there, so you don't need to do anything with powers. Now, you got some powers that are the same here. Okay, both of these have x to the first power. So since I got 2 of them that are the same, I want to draw out my blanks. Now, x second's kind of the highest, so blank x to the second plus blank x plus blank. So x to the second, we have 12 as the coefficient. For x, that's the x to the first, and we have 2 of them, so we have to combine those as like terms. So I add the coefficients, 27 plus negative 4, and that's 23. And then our constant we have is negative 9. Okay, and that's the product. Now, we're not doing this on the final, but when I had you set up those boxes where you did GCF and then that table, you're trying to take this and get back to here. Okay, that's what you're trying to accomplish. That's not going to be on your final because we just touched on it. Okay, number 5, we got x. We got 2 parentheses, so if there's no sign, it must be multiplication. So make sure all the x's have coefficients in the front. So that's a 1, and that already has a 6. Okay, now start with your rainbow. So take your 1. And you distribute it to everything in this other parentheses, not the 4 though. 1 to 6, 1 to negative 5. So this time I did 3 rainbows. So I got to write that 1x term down 3 times and then write the things I'm multiplying it by. So I'm multiplying it by 1x to the second power. I'm multiplying it to 6x, and I'm multiplying it to negative 5. Okay, then we cross that out. And now we distribute the 4, okay? 3 times with that too. So 4 times, 4 times. And it's the same 3 things. This problem's annoying just because it's a little time consuming, but that's all right. So x, well, everything needs a power. 1, 2, 1, 1, 1, and then no x and then 2, no x and then 1, and no x at all. Okay, now I'm ready to multiply. So 1 times 1 is 1. Then on the x, you got to take 1 plus 2, which is 3. So that's 1x to the third power. Okay, 1 times 6 is 6. Then on x, you take 1 plus 1, which is 2. 1 times negative 5 is negative 5. Then on x, you're just going to have the 1 power. Okay, and then 4 times 1 is 4. Then on x, you're just going to have the 2 that's here. You don't have to add. 4 times 6 is 24. Then on x, you're just going to have the 1 power. Then 4 times negative 5 is negative 20, and you're not going to put an x on that at all. Now, you got some powers that are the same. True, that's your only third power, but I've got 2 second powers, 6 and 4. I've also got 2 first powers. With negative, I'm going to draw arrows instead of circle because I don't want you to be confused. Those are both first powers. So we got some like terms in the mix. So x third would be the highest, followed by x blank x squared plus blank x plus blank. So x third, you got 1. X to the second, I want to combine 6 and 4. 6 plus 4 is 10. That's pretty obvious. X, you're looking at the first powers, and you have these right here. So you need to go negative 5 plus 24. It's 19. See? Yep. So 19. And then for constants, you just have the negative 20. Okay? And fortunately, in this class, we never have to take this and get back to here. Usually we take this and get back to 2 parentheses with just 2 things in each one. As far as how you get from here to here, you don't really want to know at this point, okay? Number 6. Now, true, you have an exponent, but you're not going to use the 3 boxes like you did on that thing yesterday because the plus sign is a game changer. What you do with a plus sign, when you do it the second power, is you get rid of it and you clone a parentheses that has the exact same thing inside of it. Okay, and this is times, so we have to do the rainbows. So here's 3, so I go 3 to 3, 3 to 5. So I write 3x down twice, and I'm going to be multiplying it by 3x and 5. Okay, now he can be forgotten, but now I have to distribute the 5. So 5 times, and then these same 2 things, use these as your same 2 factors. Okay, so 1, 1, 1 and nothing, constant, 1, constant, constant. Okay, so 3 times 3 we know is 9. Then on x we take 1 plus 1, which is 2. Okay, 3 times 5 is 15. Then you just got x to the 1. 5 times 3 is 15. You just got x to the 1. 5 times 5 is 25. Okay, now these 2 powers are the same, so those 2 are like terms. So since I'm going to be adding some things, draw your blanks. Now you're like, the reason I'm drawing the blanks is so people don't get confused and add the powers. Okay, these are set in stone. Okay, so x second you got 9. X you got these 2, 15 plus 15 is 30, and then you got 25. Okay, that's the product. See, doing the 3 boxes isn't going to allow me to get that. So I have to clone the parentheses, use the rainbows. Okay, then last problem of the video. A picture has a length of 20 inches and a width of 25 inches. That's in the middle of this picture here, so 20, 25. You're going to build a rectangular border around the picture. Okay, so before I worry about what I'm doing, let's measure the dimensions of the whole thing. So I measure across here, and I mark where that middle starts and ends. And then from here to here, look straight up. You see a 20. Now, I don't know the edges, so I'm going to call them x. They're both x. They can both be the same variable because they're both the same length. You build a picture around a frame, it's going to be the same way all the way around. So you can constantly use the same x variable. It's not like, they're different. Okay, then I measure the width. So from here to here is 25. And then the edges I don't know, but they're the same as we have here, so we can call those both x's as well. We can use the same variable. Okay, so it's very important that you do that. Now write a polynomial expression that represents the total area of the picture and the border. So area, you make 2 parentheses, multiplication, and this is my length parentheses, this is my width parentheses. So our length is the bottom part. Now there are 2 x's on this. So you want to put 2x, not just x, plus 20. 20 is a constant. Now the width. Well, you got 2 x's and a 25, so 2x plus 25. Now, forget that this is even a story problem and start doing your rainbows, okay? So 2x, 2 to 25. So 2x, 2x, and you're going to multiply by 2x and by 25. Okay, that's done. Now you got to repeat the procedure with 20. So 20 times, it's the same 2 factors, 2x and 25. So 1, 1, 1 and nothing, nothing and 1, and then nothing, nothing. Okay. All right, now 2 times 2 is 4, and then x, you got 1 plus 1, which is 2. Okay, you multiply the coefficients, but you add the powers. Okay, 2 times 25 is 50, and then for x, it'd just be to the 1 power. 20 times 2 is 40, and then there's an x, but that's the only one I have, and it'd just be to the 1 power. You don't have another power you have to add to x. Then 20 times 25 is 500, and that's a constant. There's no x's in that product. Okay, you got some powers that are the same right here. So blank x to the second, because that's the highest power I came up with, plus blank x plus blank. So x second, we got 4. X, you got 50 plus 40, that's 90. Then you got 500. That's a product, okay? Now, use your expression to calculate the width of a frame that's 4 inches. Now, what that means is these x's that we had, well, we now know x is 4. So put equals x next to that 4. And that means we replace the x's with the number 4. So write out what your thing. You got 4. Now, empty your parentheses, then second power, plus 90, empty your parentheses, plus 500. And in those parentheses, where x used to be, now 4's in there. Okay, and I can find what this equals on my calculator. Okay, you don't have to do the please excuse my dear Aunt Sally. You got a 4, and then you open up a parentheses and put 4, close it, second power it, plus 90, parentheses 4, plus 500. Okay, I got 924. Now, I'm not going to freak out if you don't label this right. It's inches, but area is square inches. So you put inches to the second power. That's what square means, second power.